Hi, this is Teacher Chris. Welcome to Math Dali. In this video, we're going to talk about Pythagorean Theorem. According to this theorem, whenever we have a right triangle, again, this is a right triangle having a 90 degree as one of the angle. If we have here the sides ABC, according to this one, if we add the squares of the legs AB, and it must be equals to the hypotenuse C. So for us to better understand the Pythagorean theorem, let's work on the following example. On our first example, let's have here the triangle ABC, wherein AC is equals to 5 cm, BC is 12 cm, and angle C is a 90 degree. Calculate the length of AB. Again, for us to be able to use Pythagorean theorem, we make sure that the given triangle is a right triangle. Having angle C as 90 degree, we can now conclude that triangle ABC is a right triangle. So we can now apply Pythagorean theorem. Going back, according to this theorem, the sum of the square of the legs of the triangle is equals to the square of the hypotenuse. Here, AB is the hypotenuse. We have here AC and BC as one of the legs. So the length of the AC square plus BC square must be equals to the hypotenuse AB and AB squared. So the length of AC is 5 and we need to square it. The length of BC is 12. We need also to square it. And for us to be able to find the length, and it must be equals to the hypotenuse. 5 square is equals to 25 and 12 square is equals to 144, and it must be equals to the length of the square of the hypotenuse. 25 plus 144, this one will give us 169, and it must be equals to the square of the length of the hypotenuse. For us to be able to eliminate the square, we are going to get the square root of both sides. So we have here AB must be equals to 13 cm. So again, for us to be able to apply Pythagorean theorem, the given triangle must be a right triangle. For us to say that it is a right triangle, there must be an angle that is being 90 degree or right angle. So here we have the example triangle ABC, wherein AC or the legs measurements are 5 cm and 12 cm respectively, and we need to find the length of the hypotenuse or the longest side. So for us to be able to find it, we use the Pythagorean theorem, and then we apply this one. So that one we have 5 square plus 12 square is equals to AB square, and then 25 plus 144 is equals to AB squared, and we get the square root of both sides. That's why we have here AB is equals to 13 cm. So let's proceed on our second example. Let's work on our second example. We have here triangle PQR. PQ is equals to 20 and QR is equals to 16, and angle R is 90 degree. Calculate the length of PR. So for us to be able to use the Pythagorean theorem, first make sure that the given is a right triangle. Having angle R as 90 degree, we are now sure that triangle PQR is a right triangle. So according to the theorem, the sum of the square of QR and PR must be equal to the length or of the square of the hypotenuse. On our second example, the missing is one of the legs. So for us to be able to solve this one, let's first write the given. QR is 16. PR is missing, PR squared, and QP is 20. Squared. So 16 squared plus PR squared is equals to 20 squared. For us to be able to find the measurement or the value of PR, we are going to use the subtraction property, or in other words, we just need to transpose 16 squared to the other side. So we have here PR squared is equals to 20 squared minus 16 squared. So PR squared is equals to 20 squared is 400 and 16 squared is 256. 400 minus 256 will give us 144, and it must be equals to PR squared. So for us to be able to eliminate PR, the square, we are just going to get the square root of both sides. Getting the square root of 144, PR is now 12 cm. Is equals to 12 cm. Again, we have here QR squared plus PR squared is equals to QP squared. We apply the Pythagorean Theorem because the given is a right triangle. So we have here QR as 16 and QP as 20 squared. The missing is one of the legs. So for us to be able to find it, we transpose 16 to the other side, or also known as the subtraction property. We subtract 16 squared on both sides. So this one is eliminated. So PR squared is equals to 20 squared, which is 400, and 16 squared is 256. 400 minus 256 will give us PR as 144. And PR squared, we need to eliminate the squared here, so we get the square root of both sides. We are now having the square root of 144 as 12 cm. So we can now conclude that PR is equals to 12 cm. On our third example, we have here two triangles, triangle ABC and triangle APB. So, given the triangle ABC and has angle C as 90 degree, and P lies on BC such that BP is 21, PC is 15, and AP is 25 cm, calculate the length of AC and AB. First, take a look what is missing. We need to find AC. So for us to be able to find AC, we have here C as a 90 degree. So the missing is one of the legs again. We have here PC squared plus AC squared is equals to the hypotenuse AP squared. So first is we are going to write down all the given. PC is equals to 15 cm. And we need to square that, plus AC, we need to find AC. So I just put it here. And then is equals to 25 squared. Instead of transposing AC on the other side, I'm going to transpose 15 squared on to the other side. This is another method of finding the AC square. So transposing 15 to the other side will give us 25 square, and then it becomes negative 15 squared. And 25 square is 625 minus 15 square is 225. So it is equals to AC square. And 625 minus 225 will give us 400. And then it is equals to the length A, or to the side AC square. So for us to be able to find the value of AC squared, we need to eliminate the square. So we need to get the square root of both sides. So AC now is equals to 20. Again, for us to be able to solve the given problem, or the first part AC, we need to apply Pythagorean Theorem. Why we need to apply this one? Because the given triangle is a right triangle, having said that angle C is 90 degree. So applying the Pythagorean Theorem, we have here PC squared plus AC squared is equals to AP squared. The length of PC is 15, and the length of AP, which is the hypotenuse, is 25 square. Instead of transposing AC to the other side, I transpose 15 to the other side. So we have here AC squared is equals to 25 square minus 15 square. It becomes negative 15 because of the subtraction property. To eliminate 15 square, we need to subtract 15 square on both sides. Or in other word, we just transpose this from here to there, and whenever we are crossing the equal sign, the sign will be the opposite. This one is positive, and then cross this equal sign, it becomes negative. AC square is now equals to 625 minus 225. Subtracting this 2 will give us 400, and for us to eliminate the square, we get the square root of both sides. Therefore, we are now sure that AC is 20. Now, let's proceed to find the measure of AB. According to the earlier, we have here AC as 20. So, for us to be able to find the hypotenuse, we have here AC squared plus BC squared is equals to the hypotenuse AB, which are missing. So we have here AC, according to the earlier example, AC is 20, and we need to square it, plus BC. As you can see in the picture, we need to add the length BP and PC for us to be able to find the length of BC. So we have here 21 plus 15. And of course, we need to square that one is equals to the hypotenuse AB. And 21 plus 15 will give us 36 squared plus 20 squared is equals to AB squared. And 36 squared will give us 1,296 plus 20 squared is 400. And it is equals to AB squared. So, 1,296 plus 400 will give us 1,696 is equals to AB squared. For us to be able to eliminate the square again, we need to get the square root of both sides. Getting the square root of both sides will lead us to using our calculator. We have here AB. The length of AB will be 41.2 cm. Again, whenever we have the following problem, we need to find AB. Earlier, we have here AC as 20. And then the length of BC, we add the BP and PC for us to be able to find the length of BC. 21 plus 15 will give us 36. And then 20 square plus 30 square is equals to AB square. 20 square is equals to 400, and 36 is equals to 36 square is equals to 1,296. Adding them will give us 1,696, and for us to eliminate the square here, we need to get the square root of both sides. Getting the square root or using our calculator, we are going to have AB more or less is equals to 41.2 cm. And that's all for this videos. See you soon.